Hello and welcome to this Robocraft 2 video. In this video I will guide you how to set up the logic for a robot like this with a wheel below that can kind of spin in any direction you want to go, so that you can go super fast while the wheel is touching the ground in pretty much any direction. So I have created this very primitive hover. Don't really mind how that one is put together. It's mostly just to get good visibility towards the wheel here. In the middle here sits an axle servo, powered one here. And the cube out from this one is 5 long, so sticks out 4 here. If you do that, the wheel will actually, will like the attachment cube sitting like this, right? The wheel will be centralized. It doesn't really look centralized right now. It looks like it's a bit towards the right, but it will actually, like when the suspension kind of pushes towards the ground, it will actually get more centralized. I can actually show this in game. If we just give this one a signal so it doesn't really spin when we enter game, we want a 0 signal to that, so let's connect it to whatever, right? You can see that it now sits a lot more towards the left than it did in the building editor. So now it actually looks a lot more centralized. So if we had put it like looking centralized in the building editor, then it would have been too much towards the left when we entered the game. Let's get started. If you have followed this guide and actually put this one here, as I did, start by removing it. I only put it there to show off the suspension and kind of how that would centralize the wheel and keep the servo from spinning like it would if we didn't have anything connected here. So just remove it and then we'll start with the logic. So I changed the design of the hover a little bit just to make it really easy to spot the wheel as we work with the logic. I also created a little bit of place here to spread out the logic and label it. I usually work with the logic really spaced out to create good visibility of what I'm doing and putting small nameplates, labeling stuff. And then once I'm done with the build, I move all the logic to like this little, really tiny space, right? But as we work with it, it's a lot easier when it's spaced out. So I can also mention that I removed all the logic from the wheel towards the seat because we don't need that and it would just make stuff not work. So let's start with the logic for strafing left and right first. For that, we want the wheel to turn 90 degrees either forward or backward, depending on if we strafe left or right. So easy way to do logic check for that is if it's less than, or if the output from the pilot seat, input A here that I will connect to the pilot seat, to the left right, is less than 0, that means we are pressing left because it will be a -1. If we leave something empty, it will be a 0 here, which means that the output here will be 1 when we press left. And we can do the opposite thing for going right. If the output is greater than 0, that means we are pressing right. Now, some people I've seen have experienced some bugginess when they have logic with empty inputs. If you are uncomfortable or afraid of it bugging out for you, I never personally experienced it, but you can always use a bit block and create, have it set at 0 with no other inputs and just connect that to all the empty inputs instead as a 0. But I don't think you need that. Now, anyway, we don't want it to try to turn if we press forward or backwards, because like if we press forward left, we want it to go diagonally instead. We don't want it to turn all the way. So we need to logic check for that. And an easy way for that is an equals mat block. So if we press forward or backward, it will be +1 or -1, which does not equal 0, which means if we equal 0 for forward backward, that means something should happen when we do these things. But something we can do right away is if we press left or right, we do want the acceleration to be on regardless, because we want the wheel to accelerate even when we go diagonally. So we can just connect that right away. So we got that done with, right? We also don't want it to turn, like if you give a plus or -1, it will turn 180 degrees. We want it to turn half of that. And I should go in here and get a constant block. And put that one to 0.5, so whatever we want happening, we want it to happen half as much. And now we just need to connect it all together. So if this is true and this is true, then we want half of this to happen. So if we press left, this will be +1 here. And if we not press forward or backward, this one will be +1. So the output here will be +1 times 0.5, output 0.5. But it should switch signs because we want it to turn in the opposite direction. So I will add a switch sign block down here. It's a bit messy, I know. And then the output here up to the servo here. And we want the opposite thing to happen when we press right. So let's take another one of these. So if we press right and not press forward or backward at the same time, we want this thing to happen half as much. And we can take this output directly because we want it to be plus 90 degrees, right, to this one. Depending on how you mounted the servo here, it could be the other way around. So you need a switch sign block for going right instead of going left. So let's kind of test this in game now. We are not moving that fast right now, and the reason for that is that we don't have any logic connected directly from just pressing forward towards the wheel's acceleration. But if I press forward and the right, you see we actually go faster now, and that's because we actually did connect left and right towards acceleration. But if we press only left and acceleration, we actually go really fast towards the left, and we can also go really fast towards the right, and it does not work that way when we press both forward and left or forward and right. So now that is working. I have ordered all the logic here for left and right, and also the check here if we're going backward and forward, but we will reuse that as well. Now we need to actually be able to go both backwards and forwards. So forward would be greater than from forward backward, and if we go backwards, it would be lower than. So if we connect the greater than 0 to forward backward, if we press forward here, we only want to have acceleration here, but we don't want the servo to spin in any direction if we only press forward. And if we go backwards, that means the output will be less than forward backward, will be less than 0. And we also want the wheel to kind of spin forward, because the wheel will be turned in the opposite direction. And we also want the servo to turn 180 degrees. It doesn't really matter if it's +1 or -1, it will turn all the way anyway. So we might as well save to CPU of not having a switch sign block and just make it turn forward 180 degrees. Let's save here. So now we can go really fast forward. We can actually go really fast backwards as well. Strafe towards the sides, but we can't really strafe that fast diagonally or that good diagonally. The hovers actually helps us strafe a little, but not nearly as good as if the wheel would be turning as well. So I ordered this one up and labeled that one as well, and now we have the diagonal strafe. So now it's time for diagonal strafe. We want the wheel to turn in 45-degree kind of angles here. We could use the servo, but that would require kind of a lot of logic. And the wheel can actually by itself turn 40 degrees, which is almost as much as 45, and using that will save us a ton of CPU. So I will use that to diagonally strafe. We already have logic checks for if we are going forward and backward and left and right, so we can also reuse that logic for the diagonal strafe. So if we are going forward, we want the wheel to turn normally like 40 degrees if we press left and right. So that's actually super easy by using a multiplication block. Connect that to the logic check we had here for moving forward towards left and right here, and towards the steering. And if we are moving backwards, we want kind of the same thing to happen. So we check, are we moving backwards? Yes, we are. And we take that one up to the steering as well. But in this case, we want it to do the opposite thing. So let's take a switch sign block here and just switch those signs around. Like if we didn't turn our wheels around, the normal thing would be like having, when you steer, it's kind of normal how the wheel turns. But because when we go backward now, the wheel will actually still face forward, it would be very strange to try to steer if we didn't kind of switch the signs for going backward steering. Let's save here. take it into test mode. So let's test everything. Forward fast, backwards fast, left fast, right fast, forward right, forward left, backward right. Everything works like a charm. So that's all for making this work, and after that is just armoring up everything, building a hover around it. And of course move all of this logic to something smaller. Hope you found this guide helpful. Give a thumbs up if you did. Maybe write something in the comment section. Well, cheers!